How do nested loops work behind the scenes? How do they help you solve problems? The most important thing I think that you need to know about nested loops is that the two loops operate at different speeds. That's really what drives the equation. A couple of analogies. First of all, nested loops are like gears in some sort of mechanical device. Okay, if you have a couple of gears that are interconnected, maybe a large gear and a small gear, and the large gear doesn't move forward until the small gear makes a full revolution. And that's really close to what a nested loop is. If you're a musical person, it's also like uh, sheet music um, or just playing music of some sort, where you have measures, right? And each measure is made up of, say, 8 beats, right? And you don't go to a new measure until all 8 beats are played, right? Or have transpired. So, go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Like that. I'm not very musical, but that's my best imitation. Once you get through all 8 notes, for example, then you move on to another set of 8 notes, and then another set of 8 notes, another set of. That's kind of what's going on with nested loops as well. Okay, so I have a visualization that fits with both analogies, uh, but visually it looks more like the gears. So here it is. So what I'm having here on, I have a large wheel, or if you want to think of it as a gear, and you notice on top of this big blue circle, which is the gear, there's a little purple circle. Think of that purple circle as our control variable in a loop. This might be our outer loop, and by tradition, the control variable in the outer loop is named I. All right, so maybe that purple dot there is the I. And what happens, and if we just have a single loop, is I starts off at some value, maybe 1, and then it bumps up to 2, 3, 4, 5, 6, 7, 8. And then the loop is done, right? And we can execute it again if we needed to. 1, 2, 3, 4, 5, 6, 7, 8. Okay. With each execution, obviously the control variable goes down until it makes this full revolution and the loop's done. That's just a single loop. Now, if you have another loop nested inside of this loop, it's really like a smaller gear inside that big gear, right? So the big blue circle here is representing the outer loop. The white circle that's contained within the blue circle is the inner loop. We now have 2 control variables, okay? The purple circle on top is our I control variable for the outer loop. Now we have this red circle on the inside, a little bit smaller, that is the control variable for the inner loop, maybe a J. All right, so we have an I and a J. All right, and just like I said with those gears, you can't move the outer gear until the inner gear has made its full revolution. All right, so the J in the J loop is going to go quickly in comparison to the I in the outer loop. All right, our red dot's going to go faster than the purple dot. So here it goes. If I'm on my I, my J in the inner loop, the I in the outer loop might be stuck at 1, and while that guy is stuck at 1, the inner variable will increase from 1 to 2, 3, 4, 5, 6, 7, 8. And then that's the end of that loop. It will reset. Okay? And now the outer loop can move forward. And boom, 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 boom. Move forward again. Boom, 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 boom. Each time the outer loop moves forward, the inner loop can go through its whole revolution. And once it finishes its whole revolution, the outer loop can go forward again. And it just repeats over and over again. And you can see the inner loop executes a whole lot more times than the outer loop. Each time it goes through its whole revolution, it gets reset. It has to go through the whole revolution again. And at this point, it's gone through its whole revolution 8 times. That outer loop, the I, has progressed forward 8 times, but each of those 8 times, the inner loop had to progress through its cycle to get where it needs to go. All right, so that's really what's going on. Now, in our next video, we'll see how this sort of logic applies specifically to the square of square problems.